Good day, everyone. First and foremost, allow me to introduce myself. I am Mark Laurente, faculty of Davao State College, main campus. Before that, I would like to extend my gratitude to Davao State College for allowing me to present my paper for this 2022 International Research Festival. And also, a heartfelt gratitude to the administration of Davao State College, headed by our beloved college president, Christine Ganiera, Sese, for her limitless support. Now, I would like to present my paper, which is actually an extension of my paper that was published in 2020. So the title of this paper is Apostol-Type of Multi-Poly-Genocchi Polynomials with parameters A, B, and C. Now, for the background of the study, the Genocchi numbers, of course, play an important role in mathematics, specifically in the field of combinatorics. This named after the Italian mathematician Angelo Ginocchi. And there are some, what they call this one, the literatures, no, really working on this Ginocchi numbers and also the polynomials. No? So started with the Bernoulli and Euler because they are related, no? That's why the researchers or the mathematicians and other researchers are really working on this type of number and polynomial. So we have, of course, now the basing from this are conjectande, no? Published in 1713. Okay, so some of the researchers find out that they able to provide relation, no, to this Euler numbers and polynomials, Ginocchi numbers and polynomials for the Euler, and also polyginocchi numbers and polyginocchi polynomials. So we have many studies, no, on this Ginocchi numbers and Ginocchi polynomials. So to name a few, we have Esa and Pang, in which they presented simple and effective algorithm, no, in which they use this Appel polynomials, which is the Ginocchi polynomials. And also one of the results in this research paper. Okay, so this Beamer presentation presented now how this S and Pang, no, came up with this algorithm. So this is just a continuation. Because I'm only given limited time, no, at most 15 minutes. So this is still quite long. And also another researchers, so we have Canwal and others work on this two-dimensional Ginocchi polynomials. And Padma and others also working on the Ginocchi polynomials, no, in their study on the steady-state concentrations of low-dose oxygen and gluconic acid in sensitive composite membrane that contains nanoparticles of anionic polymer glucose oxidase and catalyst embedded in a hydrophobic polymer. And of course, now we have the convergence analysis now is being discussed. And there are many ways now how to define the Ginocchi numbers from this references 1, 2, 3, 4, 5, in which defined by this exponential generating function, which is 2t over e to the t plus 1, in which this is just actually the summation of this g sub of n, t to the n, over n factorial, where n is from 0 to infinity, where absolute value of t is less than pi. So we have here the first few numbers of the Ginocchi. So as presented in this beamer. And also, J. M. Gandhi, no, worked on the conjectured Ginocchi number. So as presented also in this beamer presentation. So generalized form, it's in the recurrence form. And we also have this classical definition of Ginocchi polynomials, as presented also in the presentation. And we also have the first few Ginocchi polynomials as presented. Okay, so based on these references also 1 and 2. And others working on the recurrence relation, we have Jordan and Stein, And we also have Domont and Vinant and Jolani. Jolani and others really work on this Genocchi numbers. Okay, so more on this literature no, for the development no, from the birth of the Genocchi numbers until the present time no, in which there are many researchers who are working no, to this kind of number and polynomial no, up to now. So generalization of Hano, I just have to read this. Okay, and also we have this development of the Apostol-Genocchi polynomials, and then it is further developed now into higher order, in which we have the Apostol-Type Poly-Genocchi Polynomials parameters A, B, and C, which was partially published, and then another extension of this one is about to publish. And also, if this will be improved no, and developed, then it can be also published in the future. So we have the following objectives. The first one is I would like to introduce no Apostol-Type of Multi-Poly-Genocchi polynomials with parameters A, B, and C, and then establish properties for the Apostol-Type of Multi-Poly-Genocchi polynomials parameters A, B, and C, such as reconciliation, addition formula, and explicit formula, and establish relationship with this Apostol-Type of Multi-Poly-Genocchi polynomials with parameters A, B, and C, such as expressing it in terms of generalizing this in terms of generalized polynomial polynomials. I'm in a hurry because the time is running now. So significance, of course, now the Genocchi numbers and Genocchi polynomials are special numbers that are actually attractive to study, which lead to extensive field of research. So we have mathematics, physics, engineering, and other disciplines. And then for the scope of limitation, we just focus on this Apostol-Type of Multi-Poly-Genocchi polynomials, where you have this notation where parameters A, B, and C are real numbers. So we have the basic concept and preliminaries, which are useful in this study. We have the binomial coefficient. So you have this one, n taken k. So I think you're familiar with this one also. And the remark of this binomial coefficient, and also theorem. Okay, and binomial theorem. So this theorem and basic concepts are we taken from the combinatorics, combinatorial mathematics or combinatorics. And also the generalized binomial expansion due to Newton. So we have the recurrence form. And then also we have the classical Stirling numbers. So we have this Stirling numbers of the second kind, which is this x to the n, is the summation of the Stirling numbers of the second kind. So S and M. And then you have x polling, polling. So where you have that n is from 0 to r. And the explicit formula now of the Stirling numbers of the second kind is given by this. And definition that it's infinite sequence. Okay, and then power series. Now Taylor series expansion also is used in this paper. And when you have a special case to be 0, I mean A equals 0, then that's the Maclaurin series. Cauchy product of power series is cited here. Geometric sequence. And then we have the ordinary generating function. And of course, we have theorem that's being cited. Okay. And remarks for this derivative, in which we can also take this term, or we apply this derivative to one of the results of this research paper. Okay, so we also have the exponential generating function theorem of the exponential generating function Stirling numbers of the second kind. And also we have the definition of this classical polylogarithmic function, which is this one. So that's why we have the multi, because we are using this multiple polylogarithms. So as defined by this admonition, this is the multiple polylogarithms. And we have the Bernoulli numbers, Euler numbers, and Genocchi numbers. and also the polynomials of the Bernoulli, Euler, and Genocchi. So we have the main results now. So we can now define that the Apostol-Type of Multi-Poly-Genocchi Polynomials with parameters A, B, and C are defined by this one, the summation of this G cells of N to the K1, K2, K3, until K of R. You have X lambda A, B, C times C to the N over N factorial, where N is from 0 to the infinity, is actually the L cells of I, K1, K2, K3. Diba? The multiple, no? Multiple polylogarithms times the quantity 1 minus quantity AB to the negative 2t over this e to the negative t plus lambda b to the t to the r times c to the r xt. Okay, so where x is any real number with k1, k2, k3 is in the positive integer, and that lambda is the complex number, and abc are positive real numbers. Okay, so we have this base now. If you have the c to be e, you can have this equation 14 as presented in this Beamer presentation. And also, if you have, okay, if you set C to E, no, it's just the same as this one, this notation. So meaning it is this. So in which being described by this equation 15. Okay, and also if we set also A1 BE, so we can able to have this equation 16. Okay, so we also have when lambda equals 1, and equation 16 gives this equation 17. And then when x equals 0, the equation 15 gives this equation 18 as presented in the Beamer presentation. And when we have this notation, without 0, but putting 0, no, it's the same as the Apostol-Type Multi-Poly-Genocchi numbers. So if walang x, if no x, no lambda number. Okay, so first result, theorem, the Apostol-Type of Multi-Poly-Genocchi Polynomials parameters A, B, and C satisfy the relation, which is this one. So you notice that we have this, the concept of the logarithm. So we have this one. So equation 19, and also another result. Okay, the Apostol-Type of Multi-Poly-Genocchi Polynomials satisfy this recurrence relation described by this right side. And also, okay, so it's my okay here. Another is that the Apostol-Type of Multi-Poly-Genocchi Polynomials satisfy the relation, which is also this one. Now, for the proof of this, you can inquire me, if you want to prove this one. I cannot give the details here. It's because this is about to publish. This is about to publish. I'm still working on the improvement of this paper. Okay, and then we have this Apel polynomial. So we have this one, the theorem. So we use the concept of this, the derivative. So when C is set to this e to the 1 to the r, 1 over r rather, we have the consequence. So which is this. Okay. Consequence, and then another consequence is also with this formula. This Apostol-Type of Multi-Poly-Genocchi Polynomials satisfy the following, which is this equation. So we have the following theorem contains the addition formula for this Apostol-Type of Multi-Poly-Genocchi Polynomials. So which is this one. So we have on the right side. So as you see, the equation is no longer fit in the Beamer presentation because I cannot really locate the problem in the LaTeX programming. Okay. Okay. So we also have this corollary. Now when we set the C to be this e to the 1 over r. And lastly, we have one of the objectives. We do the relationship with the Apostol-Type of Multi-Poly-Genocchi Polynomials and the Bernoulli polynomials. Actually, this one, the explicit formula involving the Bernoulli. So for the proof of this one, you will see the importance of the Bernoulli polynomials, and you will see the connection of this type of polynomial. So it's not also fitting in the Beamer presentation, but I can give you the paper, if you want to know more about this topic. Okay, so these are the references that I use and also cited, and I thank you, for giving your time to watch and listen this research paper. And again, thank you, Davao del Norte State College. God bless us all. Carpe diem.